So in the previous video, we talked about the different types of particles that are even smaller than atoms. The ones that we're going to care about are the electron, the proton, and the neutron. In this video, we're going to imagine how an atom is put together using these subatomic particles. This is something that scientists have figured out over the course of many years. So I'm going to give you the final result and then talk a little bit about how we've come to figure out like the masses of the different particles and how we know that it looks the way that it does. So the atom has sort of two basic parts. In the middle, we have the nucleus. And this is composed of just protons and neutrons. And this is tiny. So the nucleus is really, really, really small in comparison to the overall size of the atom. If we want to get into sort of rough numbers, the size of the nucleus is something like 10 to the minus 14 meters, whereas the overall size of an atom is something on the order of 10 to the minus 10 meters. So it's about 10,000 times smaller than the size of the entire atom. So nucleus, very small, and it's all the protons and neutrons are packed in there. And if you remember, the protons and neutrons are a lot heavier than the electrons. So all the protons and neutrons are in the nucleus in the middle of the atom, and so this is the heavy part of the atom. And then around that, we have, not really as particles, but sort of as a cloud. So I'm going to draw this like this, are the electrons. And they're not really in any specific place, but they're sort of around, the nucleus. So we could think of this as being mostly empty. In this area where the electrons are sort of going around the nucleus, and most of the mass, or in fact almost all the mass of the atom, is located in this heavy part, this nucleus right here. So if we zoom in on here, what we have here are protons and neutrons sort of packed together. So this is an example of a helium nucleus, helium being one of our atoms. Helium has 2 protons and 2 neutrons in its nucleus. Typical helium does. And to match those 2 protons orbiting isn't quite the right word, but around the helium atom, we're going to have 2 different electrons to match the charge. So in a regular atom, the number of positive and number of negatives will be equal to each other. So the atom is electrically neutral. So there's no positive or negative. Now, that's not always the case, and is what will lead to what we call ions, where there's an imbalance between the number of protons and the number of neutrons. Okay, so how do we know all this? How do we know that the nucleus is this small part of the middle of the atom that's really heavy and the electrons are sort of all around this? Well, there's a really famous experiment that was done. Whoops. And this is a picture. Let me zoom in so you can read this a little bit better. But this is a representation of an experiment that was done by Ernest Rutherford. So this is the Rutherford gold foil experiment. And in this experiment, Ernest Rutherford, who was a physicist, used what's called an alpha emitter source, and we would call this a radioactive source today, but at the time they just knew it emitted what we call alpha particles, which actually happened to be that helium nucleus I was showing you before, where it has two protons and 2 neutrons. So it's a small heavy particle coming out of this alpha emitter. And Ernest Rutherford had taken, and his students, it wasn't just him all by himself, had taken a piece of gold and smashed it so flat, made it very thin, and was shooting the alpha particles at the gold foil, and then around it was sort of photographic film that would be able to see if an alpha particle hit it. It would light up. And so what you'd expect, what he was trying to figure out is, what is the shape of an atom? What does it look like? And what he saw was that most of the alpha particles, when they went through this gold foil, most of them passed straight through. And so what we have here is on our B and C here, this was the what Ernest Rutherford expected. He thought that there's this diffuse positive charge. They knew that atoms were neutral. There were as many electrons as protons, but they thought that charge was spread out. And so what you see is that mostly these alpha particles would just go straight through, and maybe occasionally get bent a little bit, like right here. But that was not what Ernest Rutherford saw when he did his experiment. When these alpha particles were shot through the gold foil, most of them went straight through. So that's this here. That's their biggest signal. But every once in a while, they get a big deflection, something like this, and even it would go backwards. These alpha particles would sometimes go backwards, which was just completely confounding him. I think he said something like, it would be like if you took a cannon, shot it at a piece of tissue paper, and the cannonball bounced backwards off the tissue paper. This was totally not what they were expecting to see. And that's often the case with science. We do the experiment because we think we know what's going to happen, but sometimes nature surprises us. And so this is how they figured out that the nucleus was this small, very compact. The positive charge was not spread out throughout the atom. It was in the small, compact area in the middle of the atom. And what was happening is, if these alpha particles hit right on to the nucleus, if they hit right on, the alpha particles also positively charged, and so they were repelled from the nucleus and bounced off of it. So most of the alpha particles went straight through, but if they did get a direct hit, and that kind of shows you, right, it only happened every once in a while because the nucleus is so small. But this is how we know that this is what the shape of the atom is. And there are other experiments you can read about in your textbook about how we know, like, the mass of the electron and the charge of the electron. There's an oil drop experiment done by Millikan. We know about radiation from Marie Curie and her experiments. But this is I think a really cool historical experiment, and really clever experiment too, to try and get at what's actually going on at something at this scale. So that gives us a rough idea of what an atom looks like. And so we'll continue talking about atoms and their structure in the next video.